We have talked about three major measures of central tendency: mean, median, and mode. Each has its own advantages and disadvantages. Sometimes we want to retain the advantages of one and yet avoid its disadvantages. This leads to other measures of central tendency that are obtained by tweaking these basic measures. We shall see two such. Both are obtained by tweaking the definition of mean. The first is called weighted mean. When we compute the mean by the formula summation xi divided by n, we are giving equal importance to all the xi's. Sometimes that is undesirable. Well, here is a simple example. Suppose that we have many agricultural plots of different areas and productivity levels. Let the productivities be called xi's. We want to find the average productivity level for all the plots. Productivity for a plot is measured as yield per unit area. If we merely add all the productivity levels of the individual plots and divide by the number of plots, then we shall arrive at a meaningless figure, because a very small plot with high productivity may not offset the effect of a huge plot with low productivity. So we should take areas and yields separately into account. Let's call the areas Wi's. We shall first multiply the productivity of each plot with its area to get the yield of that plot, sum these to get the total yield, and divide by the total area to get the overall productivity level. This formula is called the weighted mean. Let's see this in action. Okay, so here is my data set. I can see three columns here. The first column gives the plot number, that's the identification variable. Then I have the productivity levels, and finally I have the areas. I am trying to find out the average productivity level but taking area into account. For example, this area is pretty high, 25.8, so naturally this will have more influence on the productivity level than, say, this plot, which is very small. So what I want to do is I want to append one more column at the end of my data matrix. So I will multiply productivity with area. Remember, these are my weights and these are the actual values that I am trying to average. So I create a new column, let's give it a name. I will call it plot times area. It's just a name. And then what I do is I hit an equality, this times this, and I hit enter. So I hope you already know that when I wrote this, then this star was just a fancy label. But when I wrote this star did carry out multiplication because it started with an equality sign. Okay, so now I am going to pull it all through and I will get this times this times this, and the entire column, productivity column, times the entire area column. So I get this. Fine. Now I need to find the total. So I need to find the total weight. So I will put a little label here, total, and here I will write this sum. So equality sum of all these things. So that is the total of all these things. This is the total area, total cultivated area under my study. Similarly, I will make it total of yield. So this is product times area is basically the yield. So I will find out the total yield. So I will write sum of all these. So this is the total yield and this is the total area. So the average productivity will be total yield divided by total area. So I will write weighted average equal to, I will make it here. So this is this quantity divided by this quantity, and that is 24.6666, etc. And if I do not want to quote it to this higher decimal place, I can just select this and try to format it. Format, I'll go into number format. It thinks it is a general format, so I will call it number, and then it will be quoted to 24.67. So that will be the average productivity computed as an weighted average. So you see, in this case we just have to do the entire computation manually, because we have one weight variable, another the main variable, we have to do the multiplication and do the entire procedure.